focus on the main points in the EOT. So the first question is list the assumptions of quantum molecular theory. So here, as you see, we have the main assumptions of the quantum molecular theory. The first one, gases consist of small particles separated by empty space. The second one, gas particles are too far apart to experience significant attractive or repulsive forces. Third point, gas particles are in constant and random motion. Number four, an elastic collision is one in which no kinetic energy is lost. So no kinetic energy is lost. And by the way, in point two, when they say are too far apart to experience significant attractive or repulsive, it means there is no significant attractive or repulsive or attractive. And last point, kinetic energy of a particle depends on mass and velocity. So the formula is Ke, or kinetic energy, equals half mv squared. M is the mass and v is the velocity. And the temperature is a measure of the average kinetic energy of the particles in a sample of matter. So these are the main assumptions of the quantum molecular theory. So let's check the first question, which is not an assumption of the quantum molecular theory. So the first point here, the first option, all the gas particles in a sample have the same velocity. Same velocity? No, they don't have the same velocity, since they don't have, because velocity is a vector. So let's say there's magnitude and direction. So since they don't have the same magnitude or the same direction, okay, so they don't have the same velocity. So this is not correct. So this is the option. What about the other options? Here, as you see, a gas particle is not significantly attracted or repelled by other gases. This is correct. Collisions between gas particles are elastic. Yeah, there is no energy, no kinetic energy lost. All gas at a given temperature have the same average kinetic energy. This is correct. So this is not correct. Second one, which of the following is not correct? Okay, not an assumption. So energy can be transferred between gas particles during elastic. Yeah, the energy can be transferred between gas particles during elastic collision. Gas particles are far apart. Yeah, so there is no significant attractive or repulsive. Gas particles are in constant random motion and in constant random motion, so they are correct. But we are looking for the not correct. Okay, the incorrect one. So here, look at this formula. Ke equals 1 over 2, equals mv squared. But there is 1 over 2. It should be here. Okay, so this is not correct. Here, which of the following is correct about gases? Here, as you see, the volume of particles is big. No, it's small. The particles experience significant attractive. No, no significant attractive. During collision of gas particles, kinetic energy is lost. No, not lost, because it's elastic. Gas particles are in constant random motion, so this is the correct, because here they want the correct option. Question number two, use the mathematical formula of Graham's law fusion to compare the relative rates of fusion of different gases and their molar masses. So this is the formula: rate A over rate B equals square root of molar mass B over molar mass A. So be careful. Here we have A, here we have A, B, B. Why? Because the rate of fusion is directly proportional to the, or inversely proportional to the square root of molar mass. Okay, so that means if the molar mass increases, the rate of fusion decreases. Okay, so the first question, neon has a molar mass of 20 gram per mole and HCl 36.5. What's the ratio of their fusion? So ratio, so we have rate over rate. What's the first one? The first one is in E. Okay, the second one is HCl equals square root of molar mass of the second one, which is HCl, over molar mass of Ne. So square root of molar mass HCl 36.5, molar mass Ne 20. You can use your calculator to find the answer. Second one, unknown gas X diffuses 1.25 times faster than N2O4. What does it mean? It means that the rate of X over rate of N2O4 equals 1.25. Okay, be careful. What's the molar mass of unknown gas? So they want me to find the molar mass of X. Okay, but the molar mass of N2O4 is given. So we know that the ratio of the rates, okay, equals molar mass of what? Of N2O4. N2O4 over molar mass of what? Of X. Okay, so you can use this formula. So here 1.25 equals square root of molar mass N2O4 is 92. Molar mass of X, we don't know the molar mass of X. So you can solve it using mental math or using your calculator. Okay, so multiply, square both sides, then you can cross multiply them, then you can solve it. Okay, so this is math. Or you can use your calculator using shift solve method. Okay, so you can find the molar mass. The molar mass here is this one. Okay, so 4 identical balloons were filled with different gases to the same volume. Which balloon does the gas effuse the fastest? Okay, so the fastest is with the smallest number. Okay, fastest with the smallest number. Lowest with the largest number. Okay, here the ratio of diffusion of N2 and SO3. Okay, rate N2 over rate SO3 equals square root molar mass SO3 over molar mass N2. So square root of molar mass SO3, this is molar mass of SO3, over molar mass N2, this is molar mass of N2. So you can use the calculator to find the answer. Here, identify the most commonly used units for pressure while converting among units of pressure. Okay, so here we have the table. Okay, so I will summarize the table. 1 atm, 1 atmosphere equals 760 millimeter mercury equals 760 torr equals 1.01 bar equals 101.3 kPa equals 14.7 psi. Okay, so this is the summary of the table. So maybe in the exam that this table will be mentioned, maybe not. So it's better to memorize it. Okay, so let's try to solve questions here. Okay, so we have kPa and we need to convert it to atmosphere. Okay, so we have kPa, so 33.6 kPa. We need to multiply by something to get the answer in atmosphere. Okay, so kPa, okay, what's the value of kPa here? Look, this kPa. So keep it here, 101 kPa, because given or upper unknown. Sorry, unknown never given. So the unknown is ATM, so ATM is 1 ATM. Look, ATM, this ATM, 1. kPa down. Then we can cancel kPa and kPa, then you can find it using the calculator. Okay, so the answer will be in ATM. Here we have 84 kPa converted to ATM, so similar to that one. Okay, so 84, sorry, 0.0 kPa times, we need to multiply by something to get ATM. So ATM here, so 1 ATM, as you see here, 1 ATM. Okay, and kPa 101.3, 101.3. So you can cancel the kPa to get the answer in ATM. Here we need to convert, sorry, this is the depth, we don't need the depth. 84, 8.4 ATM. We need to convert it to millimeter mercury and kPa. Okay, so times what? ATM. Where's ATM? ATM is 1 ATM, so we keep it down. Okay, and we have millimeter mercury. Millimeter mercury is 760. So this is 760 millimeter mercury. Then you can cancel ATM and the ATM to get the answer in millimeter mercury. If you convert it to kPa, so 8.4 ATM times conversion to get in kPa. So it should be in kPa. So here kPa. What do we have here? ATM. So this is ATM. Unknown over given. So kPa, where's kPa? kPa is this 103.4.3, sorry. And ATM, 1 ATM. So 101.3, and here we have 1 ATM. So cancel out the ATM, you can get the answer in kPa. Number 4, partial pressure. So use the mathematical formula of Dalton law. Dalton's law is the partial pressure law. So total pressure equals P1 plus P2 plus P3 plus Pn. Okay. So here, as you see, what's the partial pressure of oxygen? Okay. So there's a gas. There's oxygen gas. Okay. In air sample. So the total pressure is this. So P total equals P plus P plus P plus P. Okay, so the first gas is oxygen. The second gas is nitrogen. Third gas is water vapor. Water vapor. Lastly, we have all other gases. Okay, so all other gases. So P total is 1.01. Sorry, 1.10 equals PO2. We don't know the pressure of O2. PO2 plus PN2 0.75 plus P water vapor 0.0056 plus all other gases 0.0044. You can use math or you can use your calculator, okay, to find the P pressure of O2. So let's move here. What's the partial pressure of water vapor? So now we need the water vapor. The total pressure is this. Okay, the pressure of nitrogen is this. Pressure of oxygen is this. Other gases, this. So pressure, total pressure equals P into plus P O2 plus P water vapor plus P all other gases. Okay, so total is 1 equals P into 0.79, PO2 0.20 plus water vapor, we don't know, plus other 0.0044. You can use the calculator to find the pressure of PO2, pressure of water vapor. Here, what is the total pressure? Total pressure, just add them. Okay, you can get the answer because they are the partial pressures. Question number 5. Identify factors that affect the partial pressure and that don't. Okay, what are the factors that affect the partial pressure? Here we have the partial pressure of a gas depends on the first one, number of moles of gases. The second one, size of the container. The third one is temperature of the mixture. So 3 factors. And doesn't depend on the identity of the gas. So independent, okay, here, look, doesn't depend on what? Identity of the gas. So partial pressure of a gas depends on what? Number of moles, yeah. Size of the container, yeah. Temperature, yeah. So all of them are correct. The partial pressure doesn't depend on what? The identity of the gas. Here we have the gas laws. So the first one, which is Boyle's law, second one Charles law, Gay-Lussac's law, and combined law. So the mother one, okay, so the main one is the combined gas law. So P1 V1 over T1 equals P2 V2 over T2. So P pressure, V volume, T temperature. Volume milliliter, liter, maybe centimeter cubed. Temperature, maybe Celsius, maybe Kelvin. Pressure, maybe ATM, maybe millimeter mercury, maybe kPa, maybe PSI, maybe bar, okay, torr, okay. So here, but just be careful because the temperature should be in Kelvin. You cannot use the Celsius, okay? So Celsius plus 273, you can get what? The answer in Kelvin, or the temperature in Kelvin. Okay, so here in Boyle's law, the temperature is constant. In Boyle's law, temperature is constant. Temperature and amount of gas. Okay, amount of gas. So here we have the temperature. The temperature is what? Is constant. Okay, so temperature is constant, so we can cancel out the temperature. So the formula will be P1 V1 equals P2 V2. Here, the pressure is constant. Okay, so bit sip. Okay, pressure is constant, so we can cancel out the pressure. So the formula is V1 over T1 equals V2 over T2. Here the volume is constant, so we can cancel out the volume. So P1 over V1 equal P1 over T1 equal P2 over T2. Combined gas law, all of them will be mentioned in the formula. Okay, so let's go. Here they said air trapped a cylinder filled with piston occupies 365.5 milliliter. This is what? This is V1. Okay, here the pressure ATM V1. What was the new volume? This is V2. If the piston is depressed, increasing the volume by 50%. Okay, increased by 50%. So the second pressure equals first pressure times what? Second pressure equals the first pressure plus 100%, which is 1, plus 50%. Why plus? Because increasing plus decreasing minus. Why 1 plus? Because here we have by 50. So we have the original value plus 50%. So that means that P2 equals P1, which is 0.985 times 1 plus 50% equals 1.4775. Okay. ATM. Now everything is ready. We have V1, V2, P1, P2. So as you see, temperature is not mentioned here. So that means that temperature is constant. So we have the main formula P1 V1 over T1 equals P2 V2 over T2. So temperature is constant. So P1 V1 equals P2 V2. Just substitute here. So 365.5 times V1. Sorry, this is the volume. The pressure is 0.985. This is the P1 times V1. This is V1, which is 365.5 equals P2. This is P2, 1.4775. Okay, times V2 you can use the calculator to find the volume V2. Okay. Next question. The volume is 400 here milliliter. So this is V1. Pressure 1 atm. P1. The volume is 2 liter. Look, the volume is 2 liter. So this is not accepted. Okay, so you have to convert milliliter to liter or liter to milliliter. Okay, because we need to keep them in the same unit. Okay, so here divide by 1000. Okay, so V1 will be 400 divided by 1000, 0.4. Okay, so we need to find the pressure. Okay, if the temperature remains the same. So as you see, the temperature remains the same, so we can cancel it out from the formula. So P1 V1 equals P2 V2. P1 1 times V1 0.4 equals P2 P2. We don't know P2. Okay, so V2 is 2. So you can use the calculator to find the answer. Okay, so this question here, this is V1. This is T1, but look in Kelvin. Okay, what is the temperature? What is the temperature? So T2. Okay, to reduce the volume by or to, no, to, okay, be careful, huh? If we have two, don't add one. So how to do it? Look, this is V1, which is 0.85 liter, and T1, which is 375 Kelvin, and we need to find the second temperature, which is T2. Sorry, T2. We don't know the T2. Okay, then V2 is what? Look, the original value times 60%. Okay, why? Because they didn't see, they didn't say that we need to increase by 60%. Okay, we need to reduce it or reduce it by 60%. No, reduce it to 60%. So the second value will be 60% of what? Of the original value. Okay, so be careful. To and by. If we have by, so 1 plus or 1 minus, depends on increasing or decreasing. So V1, which is 0.85 times what? Times 60%. Okay, so you can find what? You can find the V2. Then you can apply the formula. Which formula? V1 over T1 equals V2 over T2, because the pressure is not mentioned here. So the pressure will cancel out. Okay, because P1 V1 over T1 equals P2 V2 over T2. So we cancel the pressure because it's not mentioned here. So V1 over T1 equals V2 over T2. So just substitute now. 0.85 divided by 375 equals V2. This value. Okay, divide by T2. You can use the calculator to find this. Okay, here. This is V1. This is T1 because this is in liter, this in Kelvin, and this is T2. So we need to find what's the volume. So we need to find V2. So the same formula. V1 over T1 equals V2 over T2. Just substitute. V1 3.45 over T1 313.0 equals V2. We don't know V2. So T2 is 348. Then you can use your calculator. Okay, here. Look at the volume. Sorry. Look at the volume. 1 liter, 1 liter. So volume is constant, as you see. So we have to cancel it out. Okay. So this is what? This is P1. This is T1. P2, we don't know P2. Unknown. This is T2. So the formula is P1 V1 over T1 equals P2 V2 over T2. So volume is constant. Cancel out the volume. So the formula will be P1 over T1 equals P2 over T2. So P1 1 over T1 300 equals P2 T2 400. Then You can find it. Okay. Here, if the pressure of the sample of a hydrogen gas is, so this is P1, okay, and this is T1, but as we said that temperature is in Celsius. Okay, Celsius is not accepted. Okay, you cannot use it in calculations. Okay, so temperature equals 20 plus 273. Okay, so 293 Kelvin. Okay, so you have to convert to Kelvin. Okay, plus. Was the Celsius temperature? Okay, but here they asked me to find the temperature in Celsius. Okay, no problem. Just convert it to Kelvin, then find the temperature in Kelvin, and the last step you have to convert it back to Celsius. How? Let's see. So we need to find the temperature in Celsius. This is what? This is P2. So now this is P1 equals 3.33. T1 equals 20 Celsius, which is 293 Kelvin. Okay. P2, which is 3.44. T2, we don't know that. T2. Okay. So the formula P1 over T1, look, volume is not mentioned. Okay. Equals P2 over T2. Okay. P1, 3.33 over T1, 293 equals P2, 3.44 over T2. So you can find this temperature, okay, using your calculator. But you know this temperature will be in Kelvin, okay, but it should be in Celsius. Okay, just the answer here is subtract, okay, minus 273 to get the answer in Celsius. Okay. Here, the point. What's the point marked by the in red? Okay, look at this point. This is what the absolute zero. Look here, represented by the graph. So what do we have here? We have pressure and we have temperature. What does it mean? It means that the volume is constant. Okay, volume is constant. It's not mentioned here. So volume is constant. So this is what this is Gay-Lussac. Question number 9. Here, this is T1. T1 plus 273 equals 273 Kelvin. This is the V1. This is T1. T1 plus, but look, we have to add 273, so 300. Okay. Here this is P2. So as you see, P1, T1, V1, P2, T2, and V2. So this is the combined gas law because there is nothing here constant, okay, except the amount of gas, okay. So the formula is P1 V1 over T1 equals P2 V2 over T2, okay. So P1 V1 over T1 equals P2 V2. So P1 1 times V1, which is 30, divided by T1, which is 273, equals P2 is 2 times V2, we don't know V2, T2 is 300. Okay, calculator. Now, question number 10. State the Avogadro's law and represent it by diagram and its mathematical equation. So as you see, Avogadro's principle states that equal volumes at same temperature and same pressure contain what? Equal numbers of particles. So regardless the type of the gas, okay? So equal volumes at same temperature and pressure will contain what? Equal number of particles, okay? What about the molar volume and what about the STP? STP stands for what? For standard temperature and pressure. So the temperature should be 0 Celsius and pressure should be 1 atm. You have to memorize them because you will need them in the exam. Okay, so 0 Celsius or plus 273 to get it in Kelvin. So 273 Kelvin. Okay. So the pressure is 1 atm. The pressure is 1 atm, and the temperature is 273 Kelvin. Okay. So under these conditions, under STP, okay, if you have 1 mole of any gas, this mole of gas, of any gas, will have a volume of 22.4 liter. So under these conditions, temperature 0 Celsius or 273 Kelvin, and pressure 1 atm, the volume of 1 mole of any gas is 22.4 liter. Okay. So how can we use it? Okay. So um, for example, we have let's write it here. Okay. We have mole, okay, volume, and mass. Okay. So to convert from mole to volume, multiply by what? By 22.4 liter over 1 mole. In opposite direction, multiply by what? 1 mole over 22.4 liter. From mass to mole, multiply by what? By 1 mole over grams, which is the value of molar mass. Okay. In the opposite direction, molar mass over 1 mole. This, by the way, this is not molar mass, this is number of grams in 1 mole. Okay, but just want to simplify the idea. Okay, and we have here, we can convert it to what? We can convert it to particles. How? Multiply by 6.02 times 10 to the power 23 over 1 mole, or in opposite direction, by 1 mole over 6.02 times 10 to the power 23. Okay, so let's check here. Equal volumes of gases at the same temperature and pressure contain equal numbers of particles. This is the statement of what? Of Avogadro's law, of Avogadro's principle. Here, what's the question? Was the volume of 7.85 mole? Okay, so let's get back. We have the volume. We have the mole, and we need to convert it to volume. So multiply by what? By 22.4 liter over 1 mole. So here we have 7.85 mole, okay, times what? Times 22.4 liter over 1 mole. Cancel out the mole, you can get the answer. Okay. By the way, you can solve it using the ideal gas law, which is PV equal nRT. Okay. But they said STP. STP means that temperature is 273 Kelvin and pressure is 1 atm. Okay. So pressure is 1, volume, we don't know the volume. Okay, number of moles, this number of moles, 7.85 times R, which is 0.0821 times temperature. Temperature is 273. So then you can find the volume. Okay. Here, how much carbon in grams? Okay, what do you have? We have the liter, right? Okay, so we have the volume at STP. But by the way, you have to be careful. Okay, we have STP. Okay, you cannot use this conversion factor if the conditions are not STP. So we have the volume. We need to convert it to mass. Okay, where is it? Here we have the volume. We convert it to mass. So first multiply by 1 mole over 24 by 22.4 volume liter. Then the answer is in mole, right? So then you have to convert to from mole to mass. So multiply by molar mass over 1 mole. So look here. We have a 22.75 liter times 1 mole over 22.4 liter. Cancel out the liter. You can get the answer in mole. Then this mole, okay, should be multiplied by what? By molar mass over 1 mole. This is the molar mass, which is more than number of grams. 44.0 grams over 1 mole. You can cancel out the mole. Okay, so this is the strategy to solve the question, or you can use the formulas. Which formula? As you know, we have in ideal gas law, we have three formulas. Okay, PV equal nRT, and M equal mRT over PV, and D equal MP over RT. Okay, you can use this directly. Okay, M equals mRT over PV. Let's see. M equals mRT over PV. So M is the molar mass. Molar mass is 44. Okay, 44 equals mass. You don't know the mass. Okay, so this is M times R, which is 0.0821. 0.0821 times T, temperature, is TP. Okay, so the temperature is 273 and pressure is 1. So divide by, sorry, times 273. Divide by pressure is 1, okay, and the volume is 273, sorry, 2.75. So you can find it. Okay, so this is another way. What's the number of moles of gases? Sorry, how many neon atoms are in 1.86 sample? Okay, so they need what? The number of atoms. Okay, what do we have? We have volume, so we have to convert it from volume to mole, then from mole to particles. So volume 1.86 liter times 1 mole over 22.4 liter, divide, okay, cancel out, so you get the answer in mole. Okay, then you have to convert it to from mole to particles. So this moles, okay, times what? 6.02 times 10 to the power 23 atoms over 1 mole. Cancel out the mole, you can get the answer. Okay, this is the ideal gas. We have two questions, question 11 and 2. In chemistry, there is no formula sheet, so you have to memorize the formulas. Okay, PV equal nRT. So these are the formulas. Okay, this is molar mass, this is mass, and this is density. And this is what the ideal gas law, which is given in the exam. Okay, we have here different values. So as you see here, this is the temperature, but plus 273. Okay, so 308. Okay, Kelvin. This is the pressure, and this is the volume. How many moles? So we use PV equal nRT. Okay, P is 7.62 times V 0.044 equals N, number of moles is not given, times R, this is R, times T is 308. Okay, you can use the calculator here. Moles, this is N. Find volume V. Temperature plus 273 equals 303 Kelvin, and this is the pressure. Okay, and this is R. You can use the formula PV equal nRT P. This P 7.16 times volume. Volume is not given. Number of moles to 0.216. R. This is R. 0.0821 times T is 303. Then you can use the calculator. Okay. This question was the molar mass. Okay, we have two formulas. Sorry, two formulas here. Yeah, because here we have molar mass and here we have molar mass. We use this if we have mass. We use this if you have density. Okay. So look at this question. What do we have? We have density. So you have to use this one, MP over RT. So density is 1.70 equals molar mass is not given. STP, okay, so the pressure is 1 and the temperature is 273. Okay, times R, this is R. Use your calculator. Okay, question number 13. Predict the conditions under which a real gas may deviate from ideal gas behavior while explaining its effect. Okay, so the best conditions for ideal gas are what? Low pressure and what? And high temperature. Okay, and if there is no polarity, that's better. No polarity. And if the size is small, okay, small size. So we have 4 conditions, okay? But the main conditions are what? Are the low pressure and high temperature, okay? So when does a real gas behave like an ideal gas? At high pressure? No, because it should be what? Low pressure. High pressure? No. Particles are close together? No. They should be what? Should be far apart. Okay, and by the way, to be an ideal gas, okay, if you have a gas and this gas wants to be an ideal gas, it should follow what? These assumptions, okay? So if they follow these 5 assumptions, that means this is an ideal gas, okay? So close together, no. Close to each other, no. Because they should be what? Far apart. Okay? When a particle are far apart, yeah, this is correct. And there's what? The attractive force is low. Or the attractive forces are low. Okay. Which of the following is not a property of carbon dioxide that's made favorite option for fire extinguishing? So carbon dioxide should be what? Should have higher density than oxygen. Okay, so this is lower density than oxygen. So this is the option. Okay. Here we have question 14 and 15 about the mixture solutions, colloid, suspension types. Okay, separation by standing or standing out, separation, filtration. Okay, Tyndall effect, scattering light. About 2 questions about all these points. So this table should be, you should memorize this table, okay? And here, and as you see here, this is the the solution is homogeneous. Colloid and suspensions are what? Are heterogeneous. The size is less than 1 nanometer here, between 1 and 1,000 here, greater than 1,000. Settling out, no, yes, no. Okay. So Tyndall effect is when scattering light. Okay. Don't forget Tyndall effect, scattering light. Okay. In solution, there is no scattering light. In colloid, there is scattering light. Brownian motion is the random jerky motion. Any random jerky motion is called what? Brownian motion. This question, okay. Why does the light appear to scattered when it falls on the mixture 1? Okay, but it doesn't scatter. It's not scattered in the mixture 2. So look at the picture. Look at the light here. Here, look, it's cloudy. Here, it's what? It's clear. Okay, so that means this is what? This is colloid. Because what? Because of scattering light. Scattering light. Here, this is what? This is solution because it's clear. So no scattering light. So here we have Tyndall effect, as you see. Okay, this Tyndall effect appears here. So one is colloid. Yeah, one is colloid. And which scatters light? Yeah, this is the correct option. Which of the following destroys a colloid? Heating and stirring an electrolyte into an colloid. Okay, I advise you, to memorize them. Okay, heating and stirring an electrolyte into a colloid. So using this, you can destroy what? A colloid. so it will settle down, okay, settle out. So so the options are 1 and 2. There's an extra option here, but it's not we couldn't I couldn't this I couldn't show it, okay. So here, which one of the following solutions, the solvent is what is solid? Solvent is most abundant, is right. So it should be what? Solid. So let's say that I don't remember was dental amalgam, okay? But it's mentioned in the table, by the way, you'll see now. Here, what do we have? We have air. Air is made up of what? Of nitrogen gas and oxygen gas and the rest of gases, okay? So this is 78%. This is what? This is 21%, and this gas are what? Are 1%. So this is the most abundant. So this is what? This is the solvent. Okay. So as you see, the solvent is what? Is gas. And look, air is made up of gases. Okay. So but they said here what? Solid. So this is not correct. Ocean water. Water is the solvent. So this is not correct because water is liquid. But they say here the solvent should be what? Should be solid. Vinegar. The solvent is water, also liquid. So these are not correct. So this is the correct one. Okay. Why do colloidal particles settle out when into a mixture? Sorry, settle out in a mixture if it's heated. When heating the colloid, okay, the colloidal particles will have enough kinetic energy to overcome the repulsion forces between the particles. Okay, so this is the correct answer. Here, what's the type of the solution of carbon dioxide in and solvent of water? So carbon dioxide is gas, and water is liquid. So gas in liquid, gas in liquid. So gas in liquid. Here, what's the solvent of air? The solvent of air is nitrogen. How to know? By memorizing the table. You will see the table now. Okay, this is the repeated question. Here, differentiate between mixtures, homogeneous and heterogeneous mixtures. Just a moment. Okay, so here, what do you have? We have what the type of carbonated water. Carbonated water is made up of what? Of carbon dioxide and water. Soda water, okay, or okay, carbonate water. So made up of what? Of carbon dioxide, which is dissolved in water. So carbon dioxide is the gas, which is the solute, which is the solute, dissolved in water, which is the liquid. So solvent is liquid, which is water, and gas is CO2, carbon dioxide. Okay, so this is the answer. Here, look, what's this? As you see, this is the suspension. Okay. Which of the following can be separated by allowing it to sit for a period? So by separate, so you can separate the muddy water, okay, by keeping it, okay, sitting for a period of time. So then it will separate, okay. So this is what this is suspension. Here, what do we have here? We have two liquids, okay, two liquids. It can be mixed together, but they separate, okay, like oil and water. Oil and water. You can mix them together, okay, but they will separate, okay. So water, okay. So this is what this is immiscible, okay. Which of the following is suspension? Muddy water. Here, yeah, this is the table. Look at the table here. For example, look at dental amalgam, okay, which is mentioned above. Okay, dental amalgam. The solute is what? Is liquid, and the solvent is what? Is solid. So look, for example, you have air. The solvent is what? Is nitrogen, and the solute is oxygen. Carbonated water, liquid and gas. Okay, ocean, antifreeze, vinegar. You have to memorize them. And by the way, the type of the solution is depends on the solvent. Okay, so if this is gas, this is gas. This is liquid, this is liquid. This is solid, this is solid. Okay, What about the colloids? So this is the table of the colloids. Okay, so you have to memorize them. And here we have miscible and immiscible. Immiscible, when you have two liquids that can be separated, can be mixed together, okay, but separated shortly after period of time, okay? So this is what the immiscible here, the definition, okay? And we have miscible, like vinegar and water. Okay, when you mix them, two liquids are soluble in each other and in any what? In any proportion. Okay, so you can mix them. Okay, like water and antifreeze. Soluble and insoluble. Soluble, like sugar and water. So the substance can dissolve in water. Okay, so we call it what? We call it soluble. Like sand and water, for example, if we have sand and water, the sand cannot dissolve in water. It's insoluble in water. So if you have two liquids, focus on miscible and immiscible. If they mix, miscible. If they don't mix or mix, then separate, they are immiscible. Okay, and soluble and insoluble. If you have gas, if you have others, okay. For example, if you have not two liquids, if you have solid in liquid or gas in liquid, so we say soluble and insoluble. Okay, and this is the repulsion between colloidal particles. Okay, so by heating, you can overcome the repulsion between them. Okay, here the calculations. Okay, we have here percent by mass, which is mass of solute over mass of what? Of solution. But be careful, the solution is what? Is solute plus solvent. Okay, volume of solution, the same. Okay, mole of solute, mole is what? Is mass over molar mass. Okay, liter, let's say that it's not given in liter, it's given in milliliter. Okay, just divide by 1,000 to get it in liter. Here, mole of solute, be careful here, kilogram of what? Of solvent, not solution. Look, solution, solvent. So kilogram, if it's given in gram, so just divide by 1,000, you get it in kilogram. Okay, mole, the same. Mole, the same. Mass over molar mass. Okay, so let's see. What's the percent by mass? Okay, of this. So percent by mass equals what? Mass of solute over mass of solution times 100. Okay, equals. They said NaCl. Okay, NaCl is the solute. Okay, how do we know? This is the substance that will dissolve in water. Okay, the substance will dissolve in water. So this is the solute, this is the solvent. Another way, look, 4 grams, 100 grams. This is the second way, because the solute is, less abundant than the solvent. Okay, so this is 4, this is 100, so this is the smaller. So this is the solute. Okay. Third way, you have water. Water is the solvent, so the other substance is what? Is the solute. Okay. So mass of the solute. What's the mass of solute? This, which is 4. Mass of what? Of solution. This is mass of what? Mass of what? Mass of solvent. Okay. So the solution is what? Is solute plus solvent. Okay. So equals solute is 4. Sorry, 4 plus solvent is what? Is 100. So here 4 plus 100 times percent. Okay. So you get the answer. Here, this is about the diluting. Okay. So what's the volume? What volume? So we need V1. This is what? This is M1. Stock solution. Look, this is the concentrated solution. Stock solution. You need to prepare this V2. This is M2. So the formula for diluting a stock solution is M1 V1 equals M2 V2. M1 2 times V1, we don't know V1, equals M2, which is 0.5 times V2, which is 0.5 also, so we can find the volume. Okay, but be careful, the volume will be in what? Look here, in liters, right? So the volume will be in liter. So you have to convert it to what? So you get the answer 0.125, okay, liter. So how to convert it back to milliliter? Just multiply it by 1000. You can get it in milliliter. Okay, question number 13. What's the molarity? Okay, molarity is what? Is mole solute over liter solution. Okay. Here they say the molarity of aqueous solution containing this substance. This substance is what? It's the solute, because it's dissolved in the solution in water to get the solution. So this is what? This is the mass. Okay, and this is the volume. Look, in liter. Ready? Here, what do we have? We have molar mass. Okay, so mole of solute. Do we have mole of solute? No, we have mass. So how to get it? Just divide the mass, which is 1.19, divide by the molar mass, which is 119, get 0.01 mole. Okay, over the volume. Is it in milliliter or liter? No, in liter. So it's ready. So this is 2. So just divide 0.01 divide by 2, you get the answer. Okay. Here, same. We have the mass and we have the molar mass, and we want the molarity. So molarity equals mole solute over volume, liter solution. Okay. So mole solute, do you have mole? No, we have mass. So just divide them. So 40 divided by 180.16 equals, get number, this number of what? Of moles. Okay. We have liter, yeah, we have liter. So 1.5 liter, and we have the number of moles. Okay. Find molality. Molality, M small. Okay. Molality, which is mole of solute over kilogram of solvent. Okay, so this is the mass, this is the molar mass. Okay, just divide them to get what? This is the mass of what? Of the solute. Okay, because they said 5 grams of what? Of sodium chloride. So this sodium chloride dissolved in water. Look, dissolved in water. So this is the solute. Okay, so since this is the substance which is dissolved which is dissolved in water. Okay, so this is the solute and water is the solvent, and just compare, you can compare the masses. Okay, 5 grams and 100 grams. So this is the solute. Another way that water is always the solvent. Okay, so different ways just to know that this is the solute. Okay, so 5 over what? 58.44 to get the number of moles. Okay, so this number of moles. And liter, kilogram. What do you have? We have here 100 grams. Okay, just divide by 1000. Okay, to get it in kilograms. So 0.1 kilogram. So the answer should be, or so the answer will be molarity equals mole. This is the mole. Divide by this. Get the answer. Okay. Which of the following express the molarity? Molarity is what? Is mole of solute over kilogram of solvent. Mole fraction. Mole fraction. How to find the mole fraction? We have two substances. We have NaCl, and we have water, H2O. So NaCl is 0.735 mole. H2O is 6 moles. Okay, so if you add them here, you will get here 0.735 of NaCl mole plus 6 mole of what? Of H2O. Okay, so how to find the mole fraction of NaCl? Mole fraction of NaCl equals mole fraction of NaCl. NaCl is what? Is 0.735. Okay, the mole of NaCl over the total, okay, NaCl. So we add here, we add here the mole of NaCl over the total 0.735 plus 6 equals, you can get the answer. Okay, so this is unitless. Okay, no unit, because we have mole up and mole down, so we cancel them out. Okay, what if the numbers here are not in the mole? Okay, they are in grams. Okay, easy. If this one, for example, in grams, just divide by molar mass, divide by molar mass to get it in mole, then solve it. Okay. Here, for example, look at this question. Okay. What did they say? They said here we have 22% of what? Of HCl and 78% of what? Of H2O. Okay. What does it mean? The total is 100%. Okay. 100%. So that means that HCl has a fraction, okay, of what? Of 22%, and H2O has 78%. Okay, so this is what? 0.22. This is what? 0.78. Okay, so HCl is 0.22. Here, Henry law. Apply Henry law. What's Henry law? S1 over P1 equals S2 over P2. So S1 is in what? In gram per liter. And pressure, maybe ATM, maybe PSI, depends on the question. So, because this is the solubility, the maximum amount of solute that can be dissolved in a solvent or solution, in a solution at a specific temperature, okay? So, solubility. So, has a solubility, this is what? This is S1. Look, gram per liter. At this one is what? P1. If the pressure on 1 liter is what? Is 24 atm, right? So this is what? This is P2. So S1 over P1 equals S2 over P2. So S1 is 0.75 over P1, which is 12, equals S2, we don't know S2, over P2, which is 24. So use your calculator to find that. S2 equals what? 1.5 gram per liter. Okay, gram per liter. So how many liters do we have? We have 1. Okay, so that means if we have 1 liter, so the mass will be what? Because they asked me to find the mass. Okay, the mass will be 1.5. Okay, because S is what? Is mass over liter. Okay, so S is what? 1.5 gram per liter. Okay, equals the mass, we don't know the mass, over the liter. What's the liter? Liter here, the volume is 1 liter. So you can use the calculator to find the mass, which is 1.5 also. Okay, so other question. S1, P1, P2, and this is S2. So same formula, S1 over P1 equals S2 over P2. Okay, S1 is 0.55 divided by P1, which is 2, equals S2, which is not given. P2 is 4. You can use the calculator to find what? To find the formula. Okay? So to find the S2, which is 1.1. Here, we have to focus on the graph. Okay, look at the graph. This is the temperature. By increasing the temperature, this is the solubility. Some of the chemicals, the solubility increases. Some of them, look at this, decreases. This is a huge or big increase or change. Okay, look here in NaCl slightly. Okay, so which substance has the biggest change? The biggest change is CaCl2. Look at the graph here. They said which is correct. Okay, so KClO3 solubility decreases as temperature increases. So let's see, KClO3 no increases. So this is not correct, because the temperature, by increasing the temperature, KClO3 increases, not decreases. Here, Ce2SO4 increases as temperature increases. Look at Ce2SO4 by 3 decreases, not correct. NaCl, the highest increase, no, not NaCl. Look at NaCl. The highest increase is CaCl2. So this is not correct. CaCl2 has a stability of equals 64 grams per 100 grams of water at 10 Celsius. So 64 grams of CaCl2 per 100 grams of water at what? At 10 Celsius. Okay. So CaCl2, 10 Celsius. Okay. So 10 CaCl2, CaCl2, CaCl2. This is CaCl2. That's right. CaCl2. Okay. Then here, this is about what? About 64. Okay. 64 what? Grams in 100 grams of water. Look at 100 grams of water. So this is what? 64 grams in 100 grams of water. Okay, at 10. This question. Graph solubility, which substance solubility initially decreases rapidly. Okay, initially decreases is what? Is this substance? Look at the graph. Okay, here regarding the compounds, try to remember, okay, that you have ionic, you have molecular. Ionic compound, okay, we have molecular compounds. Okay, ionic compound, you have NaCl, which is table salt, table salt, and you have the gypsum. These we have, we have um, other examples, but these examples are mentioned in the book. So NaCl and gypsum. Okay, gypsum. Okay, molecular, you have oil and sucrose. Sucrose. Okay, so just try to remember them. Okay, so 3 is molecular. Yeah, 3 is molecular. They want the correct. Okay, so 3 is molecular. 3 is molecular. Yeah, oil is molecular. Yeah, insoluble water. Yeah, this is correct. 2 is ionic. Yeah, 2 is ionic. Dissolve in water, no, gypsum doesn't dissolve in water because of the strong attraction between the ions of the gypsum. Okay, so this is not correct. By the way, NaCl, okay, and sucrose dissolve in water. This dissolve in water. Gypsum and oil, they don't dissolve in water. Okay. So 3 is molecular compound. 3 molecular. Yeah, molecular. Dissolve in water? No, oil doesn't dissolve in water. 1 is ionic. No, incorrect. Because this is molecular. Here, why sucrose dissolves in water while oil doesn't dissolve that doesn't dissolve in water, or doesn't form a solution. Because sucrose molecule is non-polar while oil is molecular. No, oil is not molecular. Sorry, uh, sorry. They said here oil is polar. Oil is not polar. Okay, oil is non-polar. Oil molecules form hydrogen bond with water. No, doesn't form hydrogen bond. If it forms hydrogen bond, so it can dissolve. But they said here that oil doesn't dissolve. Okay, sucrose or sucrose can form hydrogen bond. Okay, sucrose can form hydrogen bond. So this is not correct. Oil molecules form hydrogen bond. No, not correct. Repeat it. Option. Sucrose molecules are polar. Yeah, okay. While oil molecules are non-polar. Yeah, this is correct. Okay, it's correct. I want to summarize something here that uh, we have 4 substances here, 4 chemicals. We have water. We have sucrose. We have oil. We have gypsum. and we have NaCl, sodium chloride, which is a salt. Okay, so regarding polarity, this is polar. Okay, or let's write it here. Polarity. Okay, polar, polar, non-polar, polar, polar. Okay, so that means sucrose can dissolve in water, oil cannot dissolve in water, NaCl can dissolve in water. Okay, can, cannot, can. Gypsum, this ionic compound, but cannot dissolve in water. Why? Because we have a rule which says that like dissolves like. Okay, so if this is polar, can dissolve the polar. So sucrose can dissolve in water. Gypsum should, okay, cannot dissolve in water. You'll see why. And NaCl can dissolve in water. Okay, but oil, because it is non-polar, cannot dissolve in water. Gypsum cannot dissolve in water because of the strong attraction between particles. Okay. So strong, this is an ionic compound, but it cannot dissolve because of the strong attraction between ions in the gypsum. Okay, so it cannot separate. Okay, in water. What about the compound? This is molecular. This is molecular. This is ionic. This is ionic. Okay. Sucrose, NaCl can dissolve in water. Okay, and sucrose can dissolve in water because of forming what? Forming the hydrogen bonding. Okay. So here, sorry, sodium chloride can dissolve in water because what? Because water is non-polar? No. Sodium is molecular? No. Water is polar? Yeah. Sodium chloride is ionic? Yeah, this is correct. Okay. Melting point? No. Here, what is the reason the gypsum doesn't dissolve in water, as I told you, because of the what? Of the strong attraction between ions. Okay. Expression like dissolves like. This is regarding what? This is regarding the polarity. Okay, polar, polar, non-polar, non-polar. Will predict what? Will predict solvation. Okay. What's the solvation? Solvation is the process of surrounding solute particles with the solvent to form what? To form solution. So we have some steps. Okay. So here, the fastest dissolving. Okay. Look, what do we have? We have, they say the fastest, okay? So granulated sugar in iced tea, no. Fastest should be fine sugar or powder sugar or granulated sugar, okay? And you have to stir the sugar in water, okay? And the water or the tea should be what? Should be hot. So that means granulated water in hot water while stirring. Fastest, okay? The slowest cube ice without stirring. Okay. Solubility. We have three terms. The first one is saturated. Okay, saturated when reached the maximum amount. Okay, so there is a kind of equilibrium between crystallization and what and solvation. Solvation when the ions separate from the cube. Okay, and dissolve in water. Crystallization when these ions get back to the cube. Okay. So if you reach the maximum when the equilibrium and solvation are in when the crystallization and solvation are in equilibrium, so you can say this is the saturated solution when you reach the maximum. Okay, if you have less than the maximum, okay, so this is what unsaturated. More than the maximum, greater than the maximum, this is the supersaturated. Okay, so they said here you can more solute can be dissolved. More solute can be dissolved. So this is the unsaturated. Okay, which of the following happens? The saturated when the solvation and crystallization are what? Are in equilibrium, equal rates. Okay, so we have finished. Okay, good luck. Assalamu alaikum.